about areas of surfaces of revolution. Let's see what this is. Okay, so we are interested in surface area, right? So let's consider the simplest case. Consider the line segment between A and B. Take this line segment and rotate this around X, and you get a surface, right? This is a cylindrical surface, and we are interested in area of this surface obtained by rotating the horizontal line, this line segment only, okay? And this line segment has a length delta x, we assume that. Okay, so this is a cylindrical surface, so we can easily expand it. So this is the green part, which is the distance between A and B, and this is the circumference of the circle here, 2 pi y. Why is that? Because we fix an x here, and the corresponding value is y, whatever this is, and then 2 pi y is going to be the circumference, the red part, and we are just interested in the area of this. Here is the width, here is the length. Just multiply them, you get the surface area of this rectangle, which is the same as surface area of the cylindrical surface, right? Okay, now we are gonna have another line segment, AB. This is a little bit slanted line. In this case, since it is slanted, we have the corresponding x values. Okay, so this line segment is a little bit tilted, right? So we have so if you rotate this AB around x, you're going to get a weird shape. It's not a rectangle, okay? However, what we are going to do, we are going to take the average of y1 and y2 as the height here, which is going to be y1 plus y2 over 2. It's the average. And then, okay, so the red one is going to be the average height, okay? Okay, and it's going to be the radius actually. Y star is going to be the radius of this circle, but we need this circle to get the length of this rectangle that we are interested in, and then we need the blue ones, okay? The blue one, so this circle is big, this circle is small. We have to find the average of the two. We can get the average of the two by using this y star. So we have 2 pi y star is going to be the it's going to be the length of this rectangle, right? Okay. Then the green length is L, so L times 2 pi y star is going to give us the area of this surface we have here, okay? Now, if you remember, we talked about AB distance, and then we looked at we rotated around the x-axis, and we get a strip like that, and we were able to find the area of that. But if we are given a function f, and if this function is rotated around x-axis like this, we are going to get, if they ask us to find the surface area of this shape of this surface, okay, then we have to add all these up, the surface area of these strips along this from A to B, okay, to get the surface area of the whole shape, okay? Then how are we going to do that? Okay, let's go back to this example. Instead of this AB is a line, okay, a line segment. If this AB was a curve, how would you do that? then you would, so instead of this L, you would need the length of the curve, okay? So you would 2 pi y star times, instead of L, you would write the length of this arc, okay? And that way you would get the area, okay? So look at this then, look. It's here too, look. Between P and Q, it's a curve now. And we are interested in the surface area. So instead of this L, it was L here, but now it's the length of this arc. So we have to deal with it somehow. But we already know how to find the length of an arc like that. We just learned. Okay, so then we got this formula. This formula says 2 pi y times, instead of L, this is the length of the arc. Okay, you know that, right? Square root of 1 plus dy dx squared dx is the length of the arc, times 2 pi y. If you integrate from a to b, you're going to get the area of the surface. Okay, if you rewrite it, this is 2 pi y is f of x, square root of 1 plus f prime x squared dx. You're gonna get that. Okay, let's look at the example here. We have a curve which is y is equal to 2x. We take this curve, we rotate it around x, and we get such a surface. And we are interested in finding the area of this surface. So how are we going to do that? Surface area is equal to x values from 1 to 2, integral from 1 to 2, 2 pi f of x. Okay, 2 pi f of x is 2 squared of x, and then square root of 1 plus the derivative of y, and square it, times dx. Okay, that's it. Alright, how about if we have the surface revolution about the y-axis? The previous ones were about the x-axis. Look, it's not very difficult. We have the curve now, x is equal to g of y. Of course, we assume that it's a non-negative function. Continues to differentiable, etc., because so that we can take the derivative and it's going to be continuous, the derivative is going to be continuous. The formula is similar. So we are going to, y is changing from c to d, so it's going to be from c to d, 2 pi, instead of, it was y before, now 2 pi x, square root of 1 plus dx dy squared times dy. Okay? What is x? X is g. What is dx dy? It is g prime y. And we got the formula. Alright, here's an example. So let's say we have a curve like this, x plus y is equal to 1, and we are rotating this around y. So this matches with this part. So then what would you do? We are going to write x in terms of y, right? Because we want to integrate over dy. Okay, x is equal to 1 minus y. This is our g of y. And then integral, y is changing from 0 to 1. Look, y is changing from c to d, 0 to 1. And then 2 pi x, which is 1 minus y, square root of 1 plus dx dy. Dx dy you can find, okay? Because we know what x is in terms of y, you can easily find it. X is equal to 1 minus y. The derivative is going to be 1. Square it, you got 1. 1 plus 1 is 2. Square root of 2 you got, and dy. So square root of 2 dy times 2 pi x. X is 1 minus y. You integrate over 0 to 1. You got the result.